Hello, my name is Tim Braun. Today is May 19th, 2026. The chiral molecule that I chose to research for week 6 organic chemistry is epinephrine. The IUPAC name for this molecule is 4,1-R-1-hydroxy-2-methylamino-ethylbenzene 1,2-diol. Common names for the molecule might depend on your knowledge of the subject. But for medical personnel, it can be referred to as both epinephrine and adrenaline. Usually people who aren't working or versed in medical terminology or the field refer to it as adrenaline. Functional groups present in epinephrine are alcohols, one secondary amine group, and one methyl group. The alcohols are denoted by the one. Here in the graphic, there are 3 alcohols, and then the amine here, nitrogen is bonded to 2 carbons and 1 hydrogen, making it a secondary amine. And then because this carbon is separated from the carbon chain, it is a methyl group. Chiral center of epinephrine is carbon, located here, shown by the arrow. It only has one chiral center because it is the only molecule within epinephrine that's attached to 4 different molecules or chains. The group priorities are as follows. The alcohol will take the highest priority, as oxygen has the highest atomic number compared to the other connections to the chiral center. The oxygen is seen facing towards us, which is proper to figure the configuration of the molecule. The second priority group will be this carbon, nitrogen, and carbon, caused by the nitrogen having a higher atomic number than this carbon or this carbon. And so from this we know that the epinephrine will be in an R configuration because the arrow will point from this priority group to this connection off of the chiral center, making it clockwise and in the R configuration. Epinephrine only has 2 isomers, and they are enantiomers, and this is because we only have one chiral center. One chiral center equals 2 possible isomers. The other isomer of epinephrine is S-epinephrine. So we have R-epinephrine and S-epinephrine. Within the body and made from the body, epinephrine acts as a neurotransmitter. It binds to adrenergic receptors in neuronal synapses. These are alpha 1, 2, and beta 1, 2. And from these receptors, they are the primary mode by which the fight or flight response is produced. It's a local effect. So things such as blood cell constriction or dilation, airway dilation, I'm sorry to correct myself. Local systemic effects that allow the body to get into a more active phase. It can also work as a hormone with as an endocrine function. I think we should think about this more as a systemic effect. So it's not producing that bronchial dilation or that blood vessel constriction at the local level, but it is signaling to all the areas of the body that this needs to happen. We can also use exogenous epinephrine, and this is where we understand the significance of epinephrine's isomers. Here we have an EpiPen and actually a new medication, an intranasal epinephrine. Exogenous means that it's not produced from within the body. We give this when someone cardiac arrests in an anaphylactic reaction or in severe shock. And the R-epinephrine enantiomer, remember we have R and S, binds much more effectively to the receptors. This gives it a more potent effect in important times, such as when a patient's heart has stopped or they can't breathe from a very severe reaction. Here are my sources, and thank you very much.